This is my primal linear program. I have to maximize this subject to these constraints. I add slack variables s1, s2, and s3 to each constraint and change the smaller than or equal sign to the equal sign. I solve this linear program using simplex algorithm. First, I choose the smallest negative coefficient in row 0. It's -2. Then I choose x2 column and I compare the ratio between the right hand side and x2. These are the ratios 2, 1, and 2. So now I choose 4 because it has the smallest ratio, and I replace S2 with X2 as a basic variable. I need to turn this 4 into 1, so I divide the x2 so I divide the s2 row, the second row, by 4. I need to turn -2, 2 and 1 into 0, so I do these row calculations. Row 0 equals row 0 plus 2 row 2. Row 1 equals row 1 minus row 2, and row 3 equals row 3 minus 2 row 2. So I know I have finished solving this linear program because all the coefficients in row 0 are greater than or equal to 0. So the result of this linear program is z2 equals 2, x1 equals 0 with x1 equals 0, x2 equals to 1, x3 equals to 0, s1 equals to 1, s2 equals to 0, and s3 equals to 2, because here we can see the basic variables s1 1, x2 1, s3 2, and x1, x3, and s2 are not basic variables, so they are equal to 0. So I generate the dual linear program based on the primal linear program. The primal linear program is a maximization problem, so the dual one is a minimization problem. On the right hand side of the primal one, we have 2, 4, 4. So the objective function of the dual linear program is 2y1 plus 4y2 plus 4y3. And here the coefficients of x1 are 2, 1, 3. So we have the first constraint, 2y1 plus y2 plus y3 greater than or equal to -1. The two other constraints, we do the same thing for two other constraints. So we add minus E1, minus E2, and minus E3 to the three constraints and change the greater than or equal to sign to the equal sign. Um, so now we apply the complementary slackness problem theorem to solve the dual linear program. Since S2 equals to 1, we have solved S1 equals to 1, we have solved S1 here. So according to the theorem, we have y1 equal to 0. The same thing for S3 equals to 2, so y3 equals to 0. And we have x2 equals to 1, therefore e2 từ đợi xíu, em đang okay, equals to sorry. So we have e2 equals to 1 here. We choose this second constraint, and we plug in y1, y3, and e2, and so we have y2 equals to 0.75, and we solve w by plugging in y1, y2, and y3. We have w equals to 3, and that's it.